more question, just a minute, teacher. Number 10, teacher.
Number 10.
Number 10, is it A, teacher? Number 10.
Yep. Number 10 is A. Just using the formula.
Teacher, go back again, teacher. Oh, that means they use formula only, teacher.
No, you should know that if the plate stay constant power supply, the electric field within the plate is constant, uniform. So it's a horizontal line.
Oh, wait, teacher, tell me again, teacher.
You must know that for parallel conducting plate, the field between the plate is uniform, constant.
Field between the plate is uniform.
So that's why it's horizontal line. If not, can use the formula. E is constant. So that's
field between the line is uniform. Okay.
That you must know. That is the fact.
Oh, that's why the E is constant, lah.
E is constant.
Okay. And then number actually 11 is the subtopic 12 1.4, right?
Haven't done yet. This is
haven't yet, right?
Potential. That's why I didn't
Okay,
ask
number 12, sir.
Number 12. Number 12, 3-point charges are fixed at the apex. That means the tip there lah, of an equilateral triangle of side A.
The answer is donkey, right, sir?
The work done to move the 3 charges to infinity is given by the expression
donkey.
So that's the potential formula you must know. Potential, the system, you just add them up for each of them.
Yeah, because they say the sum of the algebraic, right, sir?
Then work done is potential energy, V times Q.
This is the Gauss's law formula, sir. Not directly, right?
This one is your SPM work. Work done equals to potential difference is work done divided by charge. Yeah, we are just using that formula, that's all. Right, donkey, correct?
Oh, sir, it's not Gauss law.
No, it's definition of potential difference, this formula.
V is velocity, Q is charge, right?
V is not velocity, V is potential difference or voltage.
Oh, okay. Just give me a minute, sir. Okay. What's that? This one is number 13 is boy, right?
13 is just using definition only, no?
Gauss's
donkey,
law.
90 degrees.
Oh. Oh yeah, because the normal, right, teacher?
Yeah,
I thought the surface is the angle or something. Sorry, mistake. Careless. Okay. This one. I have question on this number 14, right? No, number 15. Sorry, number 15.
Number 15. Number 15, Gauss law. A conducting sphere of radius r is charge positive, which is the graph of electric field strength E against distance x from the center of the sphere. T is conducting sphere. So inside the sphere, the electric field is 0 because the charge is all on the surface. Outside, it just follow E over, is proportional 1 over R square law or inverse square law. The answer is B, why? This one is for potential. Okay. Yep. Okay or not? Any problem? Yes, Rini, any more problem? Any more problem?
Hello, sir.
Yes, what happened?
No, sir, suddenly my what phone turn off already, lah, sir, all of a sudden. I don't know why nowadays my phone becoming faulty already. Suddenly.
Oh, you didn't use
Sorry,
notebook
sir.
lah. Didn't use notebook.
No, I mean, wait, you mean laptop, sir?
Laptop.
No, because sometimes I don't know why, like, sir, the laptop one, like the voice, like sometimes glitch, but the phone one I can hear properly. I
Is
prefer
your
using phone.
battery 40?
No, my battery 76 only.
Because if it's 40 battery, you have problem like voltage. I also have problem. The thing just disappear and then come back again.
No, just sometimes my phone right randomly it'll off, out of a sudden it won't tell one, it'll suddenly off.
I see something is wrong lah.
By been using this phone for more than a year, I need to go check it out first, lah. Suddenly it just turned off just now.
Okay, next question.
So why is this boy,
Memory work This one inside there,
but then
zero. Outside there, follow the inverse square law. Yeah, you must know that inside the sphere, the charge is 0. Outside the sphere is on the surface. So outside it behave as a point charge, inverse square law. Inside the electric field is 0. So it's B. A is a potential.
wait, let me get this straight. Between inside and outside of sphere, right, teacher?
Yeah.
So inside, since they say conducting of sphere R is charged positive, right? Did they mention was it inside or outside? Teacher?
This graph is for inside and outside. That's the radius of the sphere. So this is inside.
Oh, the big R is the radius inside the
Big R
sphere,
is the radius. X is the distance from the center. So inside there, there's no charge there. So no electric field.
So that means it's increasing, the distance is increasing, but the electric field is decreasing, right?
That's outside.
But then the positive charge, teacher?
Positive charge on the surface.
On the surface means you mean inside or outside? No, outside. Sorry, yeah, outside, right?
Yeah, on the surface of the sphere. So it
I
behaves.
always thought it's
The
inside
charge
of
is
the
at the
sphere.
center of the sphere.
I always thought it's in the sphere,
Okay, next.
Just a minute, sir. Oh, sir, one more thing, sir.
Yeah.
the teacher always said, right, teacher, but that like every like his aim, right, like for one chapter need to finish it within a span of 2 weeks.
Yeah, he has planning, he has structure. So I think the syllabus will tell you how many hours you need to do for each
No,
topic.
because he said next week he will finish this topic already.
Yeah.
Yeah. And teacher, right, this semester, right, my friend told me it's only chapter 1 coming out.
Okay. Yep.
And I
What's the
heard, right,
next?
sir, the whole STPM 2 exam, right, it's objective alone, right? Okay.
Yeah.
Like 15 objective questions, right? 5 come from chapter 1 and chapter 2 itself.
Is it?
5
Oh,
itself.
okay.
Yeah. So it's like study chapter 1, chapter 2 properly, like you 5 objective questions can do good already, actually.
Okay. We won't bother about all those. That one we can
Okay,
worry later on.
next one, number 16. No, 16. Yeah, 16.
16. Charge Q is fixed at the center of a square W, X, Y, Z. The side is A. Another charge Q, small q, at X. There's a charge
Answer
there.
is A, right?
It's moved from X to Y. What is the work done to move the charge Q from X to Y? Okay, let's see. X and Y are, there's your charge there. We are moving this charge there, Q. So you must know that the equal potential surface for this Q, big Q is a sphere. So X and Y are actually radius. They are actually on the surface of the sphere. The radius is the QY or QX.
X and Y on
So
the
they are equal
surface of
potential
the radius.
surface.
The X and Y are on the surface of the sphere.
So
Okay.
potential surface, no work is done.
Yeah,
Right?
teacher,
Like
because
gravity, you move
because
at
it's
the
not
same
moving
height
towards the
with the
charge,
same
right?
speed, no work is done.
Sorry, teacher, what?
It's just like gravity. You move the same height, moving the same speed, there's no work done. Right?
Oh yeah, and he's at the same line, right? Somehow.
Same like here. X and Y are on the equal potential surface. Okay, next question.
Where answer? Teacher, what does equipotential mean actually?
We haven't done yet. That's why I say you are too fast. I give you work to do. You just concentrate on that. Equal potential means they are at the same potential. No work is done.
Okay. They are the same potential, no work done. Okay.
If it's gravity, they are at the same height above the surface of the earth. So no work is done if you move at constant speed. Same idea.
So what you said, if height means no what?
If it's on the earth at the same height, you move at constant speed, there's no work done because it's an equal potential surface.
Okay. Same potential, no work done also.
Same
Okay.
potential, no work is done.
And height and also gravity.
Gravity is the same, height is the same. So the potential energy is the same at every height if the speed doesn't change. Okay, next question.
Okay. Oh, 17, teacher. Wait. No. Is this chapter 1.4, teacher? 17.
Yeah,
Okay. Then skip that first, teacher. 1 minute, teacher. Teacher, number 18 also no, right? Teacher is also 1.4, right?
Number 18.
Teacher, right?
Yeah.
Okay, number no, number 20 also cannot do. Number 21.
It's also potential. Haven't done yet.
Oh, this one also potential lah.
Yeah.
Oh, I tried. So never mind, later discuss saja. 22 also potential. 23 not potential, right?
23. 23, not electric field.
It's not right.
Uniform electric field. 12.3. A positive charge oil drop stays stationary in the electric field between two parallel horizontal plates as shown in the diagram. The potential
Answer
difference
C.
between the plate is fixed. When the
Answer C.
separation between the plate is reduced, the oil drop.
No, no. Wait. They say reduce, right, teacher? So reduce means reduce means that means they remain stationary, right? A.
Let's look
Either
at
A
what
or
the physics involved. For the oil drop to be stationary, the upward force equals the downward force. Upward force is the electric force, right? The positive charge is attracted by the negative plate. Downward force is the weight. So what will happen? We replace the E with V over D, right? Potential difference and the separation D. Then we can see remain stationary, no, right? When you reduce D, you are making the force larger, so it cannot remain stationary. Electric force is larger, so it will move upwards. Force with constant velocity, no. If it's in equilibrium, then it can, if it's moving, then it will fall with constant velocity. In this case, since there's an electric force larger, it will accelerate upwards, which is what we have true. Right? The electric force is greater than the weight. So it will accelerate upwards. It won't accelerate downwards. So answer is C. Okay. If we reduce
correct. But
reduce D, we are changing
wait,
this value already. Changing the electric force already.
if you reduce D means we are changing the we are changing the D lah. That means
Yeah, not no more in equilibrium already. The electric force is now larger than the weight. Okay.
1 minute, yeah. Teacher, electric force is VQ over D, right, teacher?
Electric force is EQ.
Oh, EQ.
Then
Okay.
E equals to V over D. All these formula must be in your head. For parallel conducting plate.
Chair, that means the Gauss's law, they can also derive to become Coulomb law also, right? Basically.
Yeah. That's why I showed you last week. You can derive Coulomb's law from Gauss law.
And opposite also. Okay. Number 26.
Initially, an electron is at rest close to the negative plate. There's a negative plate. There's a positive plate. There's an electron. Of a pair of parallel plate as shown in diagram. The electron then moves towards the positive plate. Which of the following is correct about the force on the electron and the electric potential energy U of the electron as the electron moves towards the positive plate. Right? Remember, it's a uniform field, so the force is constant. So the force is given by E times E. E is the charge on the electron. So the force is constant. Potential energy, right? In this case, potential energy is just your work done, which is just your Q times your V. So positive has higher potential, negative has lower potential. So it's moving from lower to higher potential. Okay. The answer given in the book is B, but I don't agree with B. I will say it's A. Lah.
Oh, answer put there B lah.
Yeah. Right? For a simple reason, the positive plate is higher potential. Negative plate is lower potential. So negative charge will move from a lower to higher potential. If positive is higher to lower potential.
Wait, positive plate high potential, negative plate
Low potential.
this one low potential. Okay. Okay. Number 24 is C, right?
24. 24 is electric potential surface. The diagram shows the various equal potential line in the form of concentric circle with center O. Which direction of A, B, C, or D is the direction of electric force? Always remember that the electric field is perpendicular to the surface. Right? Electric field line always point towards lower potential in the radius, along the radius or radially. So answer is C. It's always perpendicular to the surface. And the electric field
So that means
along
the
the
point
radius.
toward the negative lah.
Point towards lower potential.
High potential is positive, lower potential is negative. That's why I went to the negative side.
Electric field is always from the charge itself. Highest at the charge and lowest far away. Okay.
Electric field always from the charge.
Yeah, I haven't teach you yet. But it's always coming out in the direction of the radius.
That means the C is going towards negative, right? Actually, right?
Say again.
The C is actually going towards negative, right?
Yeah. The electric field is always starting from positive and end on negative charge.
Okay. Yeah, 27.
Isolated large metal plate is positively charged. Which of the following is not zero? A. The potential difference between the points on the surface of the metal. Right? Remember the surface of the metal is all the same potential. So no potential difference. So potential difference is zero. That means from one point to another point, they have the same potential. The electric potential is the surface of the metal plate. Right? Potential has a value and it's constant. It's not zero. Potential difference is zero. If you take it because the potential is the same along the surface.
Let me recall this, teacher. Potential is not zero, but potential difference is zero.
Potential difference means it's between 2 points. So if the potential is the same, there is no current flowing. Right? The charge will remain stationary on the surface. It doesn't move. This is an old term. Electric field intensity is electric field strength. Inside the metal, we will change the new zoom soon, 10 minutes time. Electric field intensity inside the metal plate. Inside a metal plate, there's no field there. The intensity is 0. Always remember, on the outside only there's electric field. Inside there is always 0 because there's no
wait,
charge
inside
there.
the metal plate, no, is 0.
Yeah.
Inside got no charge.
Inside no charge at all. The charge always on the surface.
That means on the surface got charge and the outer one. Right, so on the surface and outside.
It's on the surface. On the surface, that's all it means. Surface, not outside. On the surface.
Oh, on the surface.
All these are memory work. Okay, next
Let's say the
question.
C1, right? You said potential difference is 0, no current flow. But then if potential means potential is the same, is it?
If the potential is the same, no work done. No? That means if you put object at the same height above the earth, it won't move. It will just stay there. Move. It won't stay. It won't move horizontally. It will just drop down to lower potential energy.
Oh, that means it won't drop horizontally. It will. What's that? It won't drop horizontally. It will drop. What's that answer?
So if the potential is the same, as we say, there's no work done, no current, no work done. So the charge won't be moving at all. It will just remain
That
there.
means it will always drop to lower potential only.
Yes, yes. Okay, next question.
Okay. Number 28, last one.
A diagram shows a charge 5 microcoulomb, center of a square size, and then the side is 0.10. That means this is a cube. The electric flux through the square is electric flux. Then there's your Gauss law. Flux is sum of the charge inside there divided by epsilon naught. So the charge inside there is 5. Change it to SI unit. And then there is your epsilon naught. Sorry, this should be minus 12.
Oh, this one use Gauss law only lah.
Yeah. Use Gauss law only and calculate.
So the sum, that means plus 5 for yeah, epsilon naught lah.
Yeah, just divide that. The one on this side. That's why they shade for you. Answer is C.
But actually I wanted to ask which formula to know when to use. That's why I always sometimes, because sometimes they won't specify, that's why.
They won't specify for you. That's why I summarize for you in your every lecture what formula you need to memorize. It's only going through the question, then you start remember the formula. You can't literally memorize it. You just work through the question. That's why I'm forcing you to do all the question. That's the math way. You keep on using it,
Like
then
I
you
just
memorize
try
it.
and see whether, like just see and whether like can do or not, like that, right?
Yeah. Okay, take 5 minutes break. Take 5 minutes break. We all
Okay,
change to a new Zoom.
Okay, one more question.
Yeah.
I saw that you post this one video on YouTube, teacher.
Yeah. Give it free.
Why, so that easier for me to collect
You
it?
want to use it, anyone to use it can use it. What's the point of keeping it to myself? Anyone can use it.
Oh yeah. I mean the first lecture, all this one are there lah, the video.
Oh yeah, searching YouTube lah. Yeah, it's all there.
No, suddenly the YouTube search came automatic.
Like that lah. I thought hard to find because I'm no name yet.
No, but then suddenly, I don't know how lah, Google so smart, and then suddenly it came on my YouTube page.
Got like that one meh?
Maybe it knows that I do class with you or something, I think. Oh, or maybe the Gmail lah.